Hello. Our lesson for the day is lesson 25 in your packet, which is geometric interpretation, basically talking about graphing, of the solutions of a linear system. So this is the first time we're going to introduce the term linear system, which basically means two different graphs or equations and looking at how they interact with each other. So all of the things that we're going to do in this lesson you have done before. This time we're just kind of putting different skills together. So the first thing that you're going to have to do on every problem, there are a total of 5. You are doing all 5. And on this video we'll walk through 1, 2, and 3. So on the first step for every single one is to sketch the graph of two different equations. So the first one we can see is in standard form. And the second one is in slope-intercept form. So for the first graph, in standard form, we're going to use our table and graph using intercepts. If you don't remember intercepts, that's when you set x equals 0 and solve for y, set y equals 0 and solve for x. Here's our equation. Here's the graph the table we're going to fill out. So our first one, x equals 0, we're going to plug in 0 here. 2y plus 0 equals 12. 2y plus 0 equals 12. We're going to divide by 2 on both sides, and we get y equals 6. And for the second one, we're going to plug in y equals 0. So 2 times 0 plus x equals 12. 0 plus x equals 12, so we get x equals 12. The way we graph this is we take these 2 points, the first one 0, 6, the second one 12, 0, and we put them on our graph. So 0, 6, and 12, 0, and we're going to get some sort of straight line and make a line from there. Great. This equation is now graphed. The second thing we're going to do is graph the next equation. Y equals 5 over 6x minus 2. Now, we have our y-intercept right here. That's where it crosses the y-axis. So I'm going to go to the y-axis, and I'm starting at -2. Then I have my slope, and we're going up 5 over 6. 1, 2, 3, 4, 5 over 6. 2, 3, 4, 5, 6. 2 points. I could do it again, but I don't need to. I just need 2 points to make a line. And I'm going to get a straight edge and make a line. And now I have graphed both of my equations. Great. Letter A says, name the ordered pair, that's the coordinate, this x, y, where the graph of the two linear equations intersect. Intersect means to cross. That's the point right there. So that's the point 6, 3. Okay? Verify or check that the ordered pair named in part A, 6, 3, is a solution to this equation. So I'm going to plug in 6, 3 to this equation to make sure it's true. So this is x, this is y. 2 times 3 plus 6 equals 12. I just plug these x and y's into these x and y's. And I get 6 plus 6 equals 12, which is true. I'm going to do the same thing to the next equation. I'm going to check that the ordered pair named in part A, 6, 3, is a solution to this other equation. So again, I have x and y. 3 equals 5 over 6 times 6 minus 2. Put that over 1. I'm going to just rewrite it over here. I get 3 equals. Multiply fractions, multiply straight across. I get 30 over 6 minus 2. 3 equals, this is equal to 5 minus 2, which is true. Letter D, could the point 4, 4 be a solution to the system of linear equations? That is, would 4, 4 make both equations true? Why or why not? I'm going to look up here on my graph to 4, 4, 4, 4. There's the point 4, 4. So what I see is that the equation, our first equation in red in standard form, 2y plus x equals 12, does go through that point, but our second equation does not. So I can use that explanation. So no, on the graph, y equals 5 over 6, x minus 2 does not go through 4, 4. I can also plug it in, 4, 4 into my equation. Y equals 5 over 6, x minus 2. I'm going to plug in 4, 4. 4 equals 5 over 6 times 4 minus 2. Put this over 1. Is it true that 4 equals 20 over 6 minus 2? 20 over 6 is 3 point something minus 2. 4 is not equal to 3 something minus 2. So we know that that is not true. We could find the exact decimal and fraction, but just by observing that this is close to 3, it's not going to work. So that's it. That's what we're doing for every problem 1 through 5. If you're ready, please go do the rest of them on your own. If you want to walk through another one, we will walk through it together. At the end, I will have the answers for each point where they intersect so that you can check your graphing. That's the only part that I will show at the end. Okay, let's move on to number 2. Number 2, same thing. We have an equation in slope in standard form, and we have an equation in slope-intercept form. So I'm going to graph the standard equation using intercepts. Making my table, x and y, and my equation x plus y equals negative 2. I'm going to find the point where x is 0. I'm going to find the point where y is 0. X plus y equals negative 2. Oops, sorry, x is 0, so then we get just y equals negative 2. Next, we have x plus y is 0 equals negative 2, which is just x is equal to negative 2. I'm going to graph those 2 points, 0, negative 2, and negative 2, 0, 0, negative 2, negative 2, 0. Get my straight edge and make a line. Okay, next equation. My next equation is in slope-intercept form. Y equals 4x plus 3. I'm going to start at my y-intercept, which is 3, right here. And my slope is 4. Now, slope is up and to the right, but we only have a whole number, which is 4. The way we turn 4 into a fraction is we do 4 over 1. So that means I'm going up 4, 1, 2, 3, 4, and over 1. If for some reason I can't go up and over, I can also do the opposite in both directions. So imagine this line is going back this way. I can also go down 4, 1, 2, 3, 4, and backwards 1. Imagine that as negative 4 over negative 1, which a negative divided by a negative is a positive. So it's the same thing. I'm going to get my straight edge. I'm going to graph my line. And there we go. Both lines are graphed. Letter A, name the ordered pair or the coordinate, x, y, where the graphs of the 2 lines intersect. That's the point right here. That's negative 1, negative 1. Verify that the ordered pair named in part A, this one right here, is a solution to our first equation. So I'm going to take negative 1, negative 1. I'm going to plug it into this equation. This is x, this is y. Negative 1 plus negative 1 equals negative 2. Is this true? Yes, this is true. Same thing for the next equation. Plugging in negative 1 and negative 1. Y equals 4x plus 3. x, this is y, I get negative 1 equals 4 times negative 1 plus 3. Negative 1 equals negative 4 plus 3. Is this true? Yes, this is true. Could the point negative 4, 2 be a solution? So I'm looking on my graph for negative 4, 2, going up here, negative 4, 2, right there. So I didn't draw it perfectly straight, but this point does go through our first line, but not our second line. So no, negative 4, 2 cannot be a solution. Solution meaning it goes through both. Because y equals 4x plus 4x plus 3 does not go through. And we can prove that by plugging it in. Our point here is negative 4, 2, x and y. Oops, I'm sorry. There we go, let me just restate that. So we're asking if this point could be the solution. It cannot, so it cannot go through because it doesn't go through. We're going to check it by plugging it in just to prove that it doesn't work. So we plugged in x, y and x. 2 equals negative 16 plus 3. Does 2 equal negative 13? No. This is just proof that does not work. Okay. I'm going to do number 3. Again, if you are ready to move on, please move on your own. You don't have to follow along, and the last 10 seconds will be your answer. Okay, I'm going to move quickly on this one because I'm running out of time according to YouTube. So, I'm sketching the graph of 2 lines. The first one, I'm going to use a table. The second one is also in standard form, so I'm actually going to use a table for both of those. So, the first one, x, y, 3x plus y equals negative 3. I'm going to use my intercepts to find 2 points. I get 3 times 0 plus y equals negative 3. 0 plus y equals negative 3. And secondly, 3x plus 0 equals negative 3. 3x equals negative 3, divide by 3. And I get x equals negative 1. I'm going to graph those 2 points, 0, negative 3, and negative 1, 0. Get my straight edge, make my line. I'm going to do the same thing for the next graph. So, make my table, x, y, with my intercepts, and negative 2x plus y equals 2. Plug in 0 for x. Oh, plus y equals 2, and I get y equals 2. Negative 2x plus 0 equals 2. Negative 2x equals 2, divide by negative 2. We get x equals negative 1. Plot my 2 points. 0, 2, and negative 1, 2. So right away we can see where they intersect. So they both go through right here. So that's my point of intersection, which is negative 1, 0. We're going to verify by plugging in 3. Negative 1 plus 0 equals negative 3. Negative 3 equals negative 3. Yes. And so that was the point negative 1, 0. Same thing, point negative 1, 0. Negative 2 times negative 1 plus 0 equals 2. 2 equals 2. Yes. Could the point 1, 4, let's go look at our graph. 1, 4. It looks like it goes through our second equation, but not our first. So no, because 3x plus y equals negative 3 does not go through 1, 4. Oops. There we go. Okay. So I'm going to post the last 2 answers, and then that's it. So here are the intersection points for number 4 and number 5. There you go.